Good morning. Today we're going to talk a little bit about probability, and we're going to focus on two kinds, on theoretical probability and experimental probability. So when I talk about theoretical probability, it is the likelihood of something happening based on an ideal situation. So it's usually based on an object. So if you have dice or a die, if you have cards, how many times it could possibly happen over how many total times it could happen. So that's based on theory. That's why they call it theoretical. So if it's based on theory, that means you don't collect any data yourself. You just look at an object, you look at an event, and figure out when it could happen. When you talk about experimental probability, it's a likelihood of something happening based on actual data and results that are done or collected. So how many times something happened over how many total times you did something. So that means that you actually either have to collect it or it's collected for you. So we're going to look at some different kinds of probability today. And we'll kind of start, first of all, with theoretical, so you can kind of see how that works, and experimental. Okay, so we're going to look at a spinner that's here. So if we look at this spinner that we have over here, if I count, I have 1, 2, 3, 4, 5, 6, 7 total spots on the spinner. So 7 total places. We're just going to have to keep that in mind. Okay, so how many total pieces are there in the spinner? So we know that there are 7 total pieces. It says if you spun the spinner one time, what is the probability that it would land on a gray piece? So if I look over at this right here, I can see that I have 1, 2, 3 chances that it happens out of 7 total. Now, anytime you have a fraction, just like we do with anything else, you always want to check to see if you can reduce if you can. So this time I can't. So I have a 3 out of 7 chance. Now, sometimes people write it like this. That would also be a way to write it, just so that you realize those are both kind of showing the same thing. Okay, the next one says, if you spun the spinner one time, what is the probability that it's going to land on a black piece? So over here, I only have the chance of black happening once. So 1 out of 7. And again, I try to reduce it. This one it can't, but you should try to do that if you can. Okay, on the next one. If you spun the spinner one time, what's the probability that you would land on a white piece? So if I look at this over here, 1, 2, 3, I have 3 pieces that it could happen on out of 7 total. Okay, now the next one. If you spun the spinner one time, what is the probability of landing on either a gray or a black piece? So if I look over here at this, gray pieces, I have 3 of them. I have 1 black piece out of 7 total. So that's a total of 4 out of 7. And that can't reduce, so that's going to kind of be my final piece. Now, all of these fractions, remember, when you get them, be sure you're trying to see if you can reduce them if you can. Now, listen, this piece right here would be considered to be theoretical probability because it's based on an object. I'm not sitting here actually spinning it 15 times to see what happens. I'm looking at the actual object or the idea and trying to figure out how many times it could possibly happen. So another common one that they use is a die. So let's talk about that. So if I have 1 die that's here, I know that the numbers that are on it are numbers 1 through 6. So I have 6 total things that could be possibly happen on a side of that. So on number 6, it says if you were to roll the dice one time, what would the probability be that it would land on a 3? So on this die, every number happens once, right? So I have 1 chance out of 6. Now, I would try to reduce that, and it can't, so I would be done with 1 over 6. The next one says if you were to roll it one time, what's the probability it will not land on a 6? So if it doesn't land on a 6, that means that it would have to land on 1, 2, 3, 4, and 5. That is actually 5 of the sides of the die out of the 6 total. So again, you can check that to kind of make sure that you have a good idea if it can reduce or not. That one cannot. You should always check. Okay, if you were to roll the die one time, what's the probability of it landing on an even number? So on the die, the even numbers would be 2, 4, and 6. So I have 3 chances of it being even out of 6. Now this is one that can reduce because these can both get divided by 3. So it's 1 over 2. Okay, again, this is theoretical because I'm not actually rolling a die. I am actually using the dice or the die itself to be able to determine what happens. Okay, so let's talk about things that are a little bit more experimental. So this one says, Amanda used a standard deck of 52 cards and selected a card at random. She recorded the suit of the card she picked and then replaced the card. So she flipped over a diamond, she'd put it on the bottom and keep going. The results are in the table on the right. So if I look at the dice, or excuse me, the diamonds, this is 5, 2 more would be 7, so I know that there are a total of 7 here. Let's see, for hearts it's 5, 6, 7, 8, 9. For spades, let's see, 5, 10, 11. So 11 there. And clubs, there are 3. Now, if I were to total all that up, that would give me a total of 30. So I know that there's a total of 30 here. And we're going to use this information as we kind of go through some questions and kind of answer them. So let's see the first question. So based on her results, what is the experimental probability of selecting a heart? So when it says experimental, you're going to actually use this data that she collected. So if I look at a heart, there's a chance of 9 out of the cards that she drew out of the 30 that she actually drew. That's your probability. Now, I can tell with both of these that 3 is going to go into both of them, so I can reduce it. So 3 over 10. So again, I could write that as this. I could write it like, oops. I guess it would help if I didn't run out of room there, huh? I could write 3 to 10. There's more than one way you can write them, just so you see it. But when it's experimental, I have to actually use the data that she collected. Okay, let's change, at least thinking about this for a minute. Let's talk about this idea. What's the theoretical probability of selecting a heart? Now, theoretical, I have to think about, okay, based on the theory of the cards that I'm using, what's the chance it's going to be a heart? So if I think of the different kinds it could be a heart, it could be a diamond, it could be a club, or it could be a spade. Those are the chances, the only chances I have in drawing the card. Now, out of the heart happens one time out of all of these. So you have a 1 out of 4 chance. So that's different. When they're talking about theoretical, then you have to think about the theory behind the cards that you're actually using. Okay, so what about this? What is the experimental probability? That means I'm going to use that table that she gave me above for selecting a diamond or a spade. So we know in her experiment, she had 30 cards that she drew. So it's a diamond or a spade. So if I look back up here, diamond is 7, spade is 11. So I'm going to put those two together. So 7 and 11 would give me 18 out of 30. And I know in this one I can tell 6 will go into both of them. So 3 out of 5. Okay, now that's based on her experiment. You got to think about that. Okay, theoretical probability. So what is the theoretical probability of selecting a diamond or a spade? So we have to use the theory of the cards. So remember, we said that was going to be hearts, diamonds, spades, or clubs. So if they want to know what the chance is to have a diamond or a spade, there's one, there's two. So there's two chances out of the four total. And again, I can reduce these both by 2. So reduce down to 1/2. Okay, gives you some basic idea then of how experimental and theoretical work.